All right. Hello, everyone. I'm really happy to be here. I'm going to talk today about agents. I'm going to try to demystify them a little bit. I found that quite a few developers I talked to recently had a hard time developing agents or defining the word agent. And I wanted to see if I could do something about that. And well, first, let me tell you about me. I'm Alex. I'm a software developer for 15, 16 years now. I lost count. I've been building everything from simple APIs, Android apps, to inferencing and training models. And right now I work as a freelancer for different projects. And one thing I'm really excited to work with is everything that's LLM-based, AI-based. So yeah, let me just go straight into the topic because we have a lot to talk about. And I want to see if we can define the word agent. Because I've been struggling to come up with a definition for what an agent actually is. And I think this is something that I really like. Intelligent actors that autonomously accomplish goals, right? So something that does something with thinking. Let's take this a little bit more into detail, right? So I would say that every agent has something, and all agents have something in common. They plan and they take steps. They retrieve data from somewhere. They interact with their environment somehow, and they remember things, right? We'll keep this in mind throughout the presentation. But for now, let's come up with a great example for something that does this as well. It's my toaster. So toasters, they plan, right? They know exactly what happens when you push the button and start toasting. It retrieves data. It knows when it gets too hot and it stops toasting. It interacts with the environment. Well, it does the toasting. And it remembers because, well, it knows when I push it down, it stays down, right? So is this an agent? Well, technically it kind of is, but we're more talking about AI agents, right? So when we talk about AI agents today, we're mainly talking about anything that, is large language model based. And usually that means that an LLM talks to a human. Let it be text, let it be video, audio, whatever, any kind of modality. And that usually means that we talk to it and stuff happens. That means it involves more than just text input output, because that's just chat. An agent goes a little further than that. It usually involves a state machine, right? We all know what a state machine does. And that means, we input information. There's logic that checks where we are in a specific flow. It remembers, where we're going. And then it, lets us have deterministic actions that happen within the system. And to interface with the environment, we run tool calls. All of these specific things we'll get into. I'm actually really curious before we continue right now. In a room, who has built an agent before? Nice. Okay, cool. Who's rolled out an agent in production? Okay, cool. I was really curious about this one because I was at GitHub in San Francisco a couple of days ago. And they asked the same question. And there were less hands than in this room for who has built an agent and who's rolled in production. Actually, it was more, but less people in SF have built agents than here. So, woo. Okay. Now, I want to start this in-depth, conversation about agents with a real-life example. Okay, so we have a fictional company. It's a German contractor, Haustechnik Keller. A regular company, we have the owner Sabine, we have Klaus the office worker, and we have Michael the technician, right? So Haustechnik Keller is a plumbing business. They do heat pump installs and all the stuff that's around it. Your heating is broken, your water pipe, whatever, all these kind of things. So a typical day usually starts with a technician being out in the field and he's just done with his install and he has a question. Something is up with the install he did. He has a question for the boss. Hey, I had to install extra fittings while I was working on this, and now there's a billing thing. So he calls up Sabine and he's like, hey, by the way, I'm done, but I'm not sure if I have to write an invoice for this because I just replaced 2 little items. Maybe the value is €1. I don't know because I'm just the guy who installs this. So he calls his boss, but she is on the road on the way to a client. So she doesn't have her computer, which means that she has to call the office. Now at the office, what happens is that Klaus is going to check on the computer. Hey, there's already There's already an offer, and we have priced this as such, and the extra parts cost this and that. Now, with this information, he still doesn't answer Sabina's question because she doesn't know how much time Michael spent at the client. So Klaus has to call Michael. He's like, hey, Michael, how much time did you spend at the client? Oh, okay, I spent 2 hours here. Cool. Thanks. Now we can update Sabina. Hey, by the way, he spent 2 hours there. He only placed 2 parts. Wonderful. Okay, now she can make a decision. This has taken around 40 minutes. Everyone is frustrated, and nobody really wants to have a workflow that's this annoying and boring, right? So this is nothing new. This has been happening for the past 100 years. We can build an API for this, right? Well, APIs work, but they have limits. So we all know if you build a service, an API, an app, whatever, we have a certain requirement for certainty, for determinism. We give our technician an app where he can input all his information. He sits there and types in everything, and he puts in searches for fitting D12. I know that's the wrong one, and it's annoying, right? So that makes things complicated. As well as if I input that there, the technician still has to wait for someone in the office to approve the change, and then it's basically the same workflow, but with an app. What we can do to make this a lot more comfortable and a lot more intelligent for everyone involved is to build a super agent. The super agent, he can do everything. He can analyze what's going on. He knows exactly what goes on in the field, how to pay, how to bill, and he knows everything, right? Agents are amazing. The only issue is we all know what happens if we give too much information to an LLM. They lose track because when we give them too much context, well, then they don't focus. So what this means is that, we're going to tell them, hey, I installed 2 D12 fittings, and now I want to know how much that cost. And he's like, I don't know. I don't know how to check that information. Great, thanks. To prevent this, what we can do is we can build models that are, agents that are more focused. Instead of building one big mega agent, we'll build several experts, each expert being the person to talk to for a specific domain. For example, our field service agent, the one at the bottom, he knows everything that's going on in the field. He has all the technical knowledge. He can answer a question about a specific heat pump model. He knows where the manual is. He can send me the PDF. He knows how much, where to find supplier lists. He knows my schedule as a technician. The office agent knows exactly the schedule and all the offers that are in the system, and the orchestrator is probably the most important one of them all, because just like in real life, somebody has to coordinate what's going on. So if you build a multi-agent system, what's quite important is that you have to make sure that these multiple agents don't go into chaos and infinite loops and lose where they were. So you can have a single agent that does nothing more than coordinate what the other agents do. And this happens by telling this agent who does what. That's basically all this agent knows. He knows who does what, and then evaluates where we go, and prevents us from having infinite loops, prevents us from having decision trees that make no sense, and streamlines the process. Our field service agent, as we discussed, he knows exactly, all the technical details and everything we need to know in the field. And our office agent is the office expert. This together lets us build a streamlined workflow where all humans can focus on what human tasks they need to do. There's a lot of things that agents can't help us with, right? For example, negotiating with clients. That's quite important if you run a small business. You have to make sure your clients are happy. And people don't really like talking to agents that much, or to LLMs, so this is still a human task. Human-to-human stuff won't change for quite a bit because it's very emotional, right? And we're emotional beings. So in this case, our field technician, Michael, can talk to our system, which will then relay all this information to the correct agent. So does the office worker. Everything they talk gets relayed to the correct agent and goes back the other way. We'll go to a concrete example in a second. But what all of this allows us is to streamline a 40-minute process down to 40 seconds, more or less. We want humans to be able to focus on what really matters. That's our task as developers, right? We want to make everyone's life easier. We want to solve problems. And this is what we're trying to achieve with systems like this. So how do we do all of this? And I want to try and dare do a live demo. Let's see if today works. So I have two WhatsApp chats here. The right side is our office chat, and the left side is our our field service chat. So I'm going to send a voice note now. Hey, I just finished all the work at our client Maya in Friedrichstraße 12, and I installed the heat pump. Everything is good, but I needed to install 2 extra fittings and had to put some tape in to fix some other stuff. And yeah, it took me like 2-3 hours. Yeah. So now what happens? We send this message to our system, and in the background, our agent's already working, hopefully. And they process this audio message, they analyze, hey, what was the intention, and relay it to the correct agents. And if everything goes well, and the demo gods are with us today, then there should be more messages appearing. But I think they're not with us today. Yeah, oh, there we go. Cool, yeah, nice. Okay, so took a while. But we got in feedback immediately. No other human had to be involved. The system knows, okay, cool, I didn't really understand how long you were there. It's vague what you told me, 2 to 3 hours. What's that? And at the same time, our office received a message about the bill that might be correct. So at this point, the system intelligently made the decision. He's like, okay, this information is good enough for me to assess, to send to the office. They can create an invoice for you. But you can also give me more detailed information. If we continue now, this invoice will be created, or our client will be billed, or we continue the entire flow and the conversation continues automated. No one has to wait for anybody, right? So this was a real life example I had for a client of mine who has a business like this and was struggling with this kind of conversation because they just waste a ton of time on it. And with systems like this, we can solve these issues. And this, well, is quite complicated to build, and that's where we're going to go now. Oh no, I clicked on the wrong slide. PowerPoint, play along. There we go. Right. So, how do we build this? Let's remember where we came from, the definition of what an agent is and how an agent works, right? We plan, we retrieve data, we interact with our environment, and we remember. So, our architecture is quite simple. The human talks via WhatsApp with the orchestrator talks to our agents. Now, if we run all of these in the same machine or in the same script, cool, we don't have to do any extra steps to make it work. But in real life, it probably makes sense that they're all their own, service or cloud function or whatever. So they're not in the same machine. The way we generate this conversation is just using regular generation prompts with our models. I have an example in a second. But that means there's no tooling or nothing for us. So we have to come up with a way to make our agents communicate. And the most common way to do this is just to run an HTTP server and have them talk to each other via requests. Which is quite simple because, well, they understand text, so we don't even have to send them structured data. We can just tell them, hey, office agent, I need this information, and the information will come. And with this structure, testing becomes horrible. Because, well, I have to send a WhatsApp message every time, so that involves more complexity, and that's not fun. So usually it makes sense that we build a CLI or some other way to interface with our agent. So in this case, our program that just ran in the background has a CLI and receives WhatsApp messages via webhooks. But what actually happens in the background? So every agent is just nothing more than chat history and a generate content request to an LLM. In this case, these are all Gemini 2.5 Flash. You can use any model, but the cool thing about building agents that are experts in a single domain is that you don't need the big fancy pro models for most requests because these tasks are not that complicated. And the Flash models are really smart. You could probably even use Flash Lite for most of them. That's the even cheaper one and even faster. That doesn't even do thinking. So what actually allows us to interact with our environment are tool calls. Tool calls are nothing else than calling functions. And Python has a specific really cool feature that's automatic function calling. So if you've ever implemented function calling or tool calling in any other framework or any other language, you know you have to define the function as JSON and then tell the code this is where my definitions are and this is what the data I want and so on and so on. The cool thing in Python is you don't have to. You can pass a function directly to the SDK, write your definition for the model as a comment, and it gets all the context from that. So much less code for you to write. In addition, it will run your agent in an infinite loop, basically, until the agent decides it doesn't need to run any more tool calls. So, for example, here, our agent in the field has two tools, find customer and check invoice status, right? So when the agent or when the field service technician sends a message to the agent and tells them, hey, I'm done working in the field at this client, the first thing that happens is that we check the laser pointer doesn't work. We check the find customer function to see what customer we are at because our system will need IDs, right? That's what we need for SQL queries and for APIs. And then after that, it will check, hey, what's the status of the invoice before we continue? Like, is this already paid? Does the technician even have to worry about this? These are two actions that happen back to back, and it would be really annoying if our system would have to go out and then tell the technician, should I check if the invoice is done? No, we want this to happen automatically, so it's less work for the human. So in any other language that's not Python, what we would have to do is we would have to write a loop that just keeps running and doing things. And it's not that much work, but it's quite nice if we don't have to do it, right? So all of our agents that we have in the system have a set of tools that they need. For our Office agent, the only thing that this agent in this case needs to do is to check or to create invoices, right? It receives messages, then asks for confirmation and creates the invoice. That's it. Our orchestrator is the most interesting thing here because, as you can see, it has our other two agents as a tool. So what does that mean? Why would I give an agent as a tool to another agent? That's just agentception, right? Well, that's the whole reason the orchestrator exists. Because if we tell each agent to talk to each other, things can get chaotic because there won't be any point where we have control over our system, right? We can obviously create code that lets our Office agent directly talk to our field service agent and then back and forth. But then we have to sync chat history. We have to sync context. We have to make sure that tool calls still make sense, that they don't run into infinite loops and all these things because they're just experts in what they do. They're not experts in coordinating. That is our orchestrator. So when we have something in the middle, this is what calls the appropriate agents when it's their turn to do things. Now, if we want all of this to make even more sense, we need to add chat history, right? So you've probably already passed context to an agent or to a model when you generate content. The only difference that you have here is that you might have to filter a little bit. Now, in this example, what I do is I save every message to Firestore, every single one, with the role that is attached to the person that sent it. And then I filter it down a little bit. Now, in real life, it would probably make sense is to actually not input the entire context, but to simplify it even more. Context engineering is the most important thing you can do. There was a study from Anthropic recently that said that you can have better results with smaller models if you have better context engineering and do a bit than you get when you fine-tune bigger models, right? So context is king, always. In this case, what we need to do is our model needs to know what happened before. So in WhatsApp, if you click yes or no, it needs to know what that yes or no refers to. So we have to send every message to Firestore and save it somewhere. And that's quite simple. I mean, Cloud Firestore is a non-relational database. All we do is we set the value and we save the entire chat history. For demo, that's good enough, but for real life, we should probably do a little bit more Simple. Now, this is all a lot of work. Coordination between these models and making sure that there's no loops. I keep saying that because that happens a lot and it wastes a lot of tokens and gets quite expensive. And making sure that you can actually test your agents apart from the tools with a regular Python code or whatever language you write in can be a huge pain, right? There's no tooling to see, okay, this request took too long, or I don't have an interface to actually talk to my agents. It's a huge pain. That is why the ADK exists. There's many frameworks like it, but the ADK is one of the nicest ones I've looked at. And heads up, we're not going to go very deep today because there's a really cool workshop later that I highly recommend. But just to get a brief overview right now. So we've just determined, and I've mentioned the term looping for our agent. The ADK has many different kinds of agents that we can use, and one that's not even listed here, which is A2A. The ADK also supports A2A, so that's inter-agent communication through different machines. In our case, we've built a looping agent. Our orchestrator just is an infinite loop that keeps continuing and waiting for user input, right? And the other two agents, they just react. They're LLM agents as defined here on the agent types. Now, if we implement our same system in the ADK, we can play around with it in ADK Web. Now, before I go there, side note, you might have noticed everything's in light mode. I prefer light mode for presentations. The ADK doesn't support light mode, but there's a GitHub issue open, so if anyone knows anyone at Google that could approve this, it's actually quite funny because in that ticket they talk about presentations and how it's really hard to present the ADK because there's no light mode. I found this when I was Googling whether there wasn't a light mode and I thought it was funny. Right, ADK. This is what, I have to close this. Right. So this is what the ADK looks like when you start it. We already implemented our agents. It's the exact same code as before with some ADK touches. And now we can talk to our orchestrator or to the agents, to the other agents directly. Now, if we talk to this wonderful agent here and we do send the same voice note as before, can you hear me? No. Okay, one sec. Let me type. Right. So we send our message to the agent, and now this is what happens. And it's way different from what we had before. We get feedback. I didn't code this. This is part of the ADK, and this is awesome. You wouldn't, like, if you've built an agent, you know exactly how painful it is to, make sure everything works. But these tools that you get here, they help you so much in debugging and seeing what actually happened, because it gives you a complete overview of all the things that happen inside your code without having to start a debugger, without having to write console logs, without having to do anything. It's just one click and you get the information and you can get all insights into your system. So here we can see, for example, that the function response from our find customer was this exact payload, and this way we can troubleshoot if we get the wrong result or if anything else doesn't make sense. We see the structure of the request. We can see that our orchestrator called the field service agent, who then ran the find customer function. And more of that, we can even see the timings for different things that happen. So we can troubleshoot our system if we are like, okay, this took way too long. Why did that take so long? So we get all the tools in the world that we could need to make sure the system runs, and we don't have to write any extra code for it. It's really, really, really helpful. Right. As I said, the ADK has a lot of things it can do. And I really encourage you to have a look at the deep dive workshop from Ankur, which is at 2 p.m. Because honestly, I wouldn't ever write another agent without using a framework like this, because it just, way too much work that you could invest in other things that are much more worth your time by actually building really cool products. I have some sample code for you that you can look at. Everything I built today is on GitHub at this QR code. Please feel free to critique it. There's a lot of vibe coding involved, but that's what we work with today. Thank you very much. I hope you guys learned something, you enjoyed it, and yes, feel free to ask questions or find me in the conference. Thank you.